Hi guys, welcome back. Today on Chem Talks we are going to have our final video of this unit, and that's going to be talking about concentration. I don't mean thinking hard, I mean about how concentrated our solutions are that we are making. Now, what fun would chemistry be unless we finally threw some math in it? And this is where math comes in. But I got to tell you, this is practical chemistry. Every time I make up solutions for us to do in lab, I'm having to do these manipulations, these calculations. So it's really important that you know and understand how to do these. So let's go ahead and get started. We're going to start by doing a little review here. The first thing we want to talk about is just review solutions. Remember, a solution is simply a homogeneous mixture of two or more substances in a single physical state. By homogeneous, we mean it looks the same throughout. Okay, the composition may vary, but it has these limits. For example, if we put 1 tablespoon of salt in water, we have salt water. If I put 2 tablespoons of salt, I still have salt water, and I can put 3 in. Right, so the composition can vary. Eventually, we're going to get to the point where no more soluble, and that's what we mean by within limits. Okay, characteristics of solutions. If you remember, they're generally less than 1 nanometer in particle size. They're not going to settle out. Gravity is not going to have effect on them, so our particles stay suspended. And they will pass through a filter paper, meaning they can't be filtered out. Remember, solutions are comprised of 2 parts that we've been talking about. The solvent, which is what's doing the dissolving, and the solute, this is the substance that's being dissolved. Okay. If something is able to be dissolved, if solute's able to be dissolved in a solvent, we say it's soluble, like we talked about in the last video with solubility. If it's not able to dissolve, we say it's insoluble. If you remember, that comes back to the chemical properties of the solvent and solute. Are they both the same? Are they both polar, both nonpolar? And that helps determine whether it's soluble or insoluble. So today we're going to talk about concentration. And concentration simply refers to the amount of solute in a given amount of solvent. It's basically a measure of the solubility of a substance. How much solute is in a solvent. And we can express it in 1 of 3 ways. The one that we're going to use for this class is molarity. Okay, we may also talk about normality when we get to acids and bases, and the other one you may hear, which we're actually not going to use in this class, is molality. So let's talk about what molarity is. Look at the word molar. That's something to do with moles. Molarity is simply the number of moles per liter of solution. So if we write that out mathematically, it's moles divided by a liter. And there's our chemical equation to figure out molarity. Real simple. We've been doing moles in the last unit with stoichiometry, and we also started the semester off with them. In liters, well, we know how to convert between milliliters and liters. So this is not a hard calculation for you guys. So if we have a 1 molar solution, it means we have 1 mole of a solute in 1 liter of a solution. So how do we make these? Well, we make them very specifically. There's a special order we do things in to make sure we get it right. And the first thing we need to get is a volumetric flask. Remember these? We saw these at the beginning of the year. Remember, the special thing about a volumetric flask is that it can be accurately measure 1 amount. For example, and that amount will be written on here. So this is a 500 milliliter. Right here, there's a little line that's been etched in. That is where we're going to fill it up to. It accurately measures 500 milliliters. It doesn't measure anything else. So we got to make sure we get the right size volumetric flask for the job. So what we need to do to make these. First thing to do, we get our volumetric flask out, and we're going to put the known quantity of solute. How much solute do we need in the volumetric flask? Then we're going to add water. We don't add tap water. Okay, we're going to add deionized water, and we fill it up to the line that tells us how much. Now, if we filled it with water first and then put the solute in, what's going to happen? Well, of course, that water is going to go up, and we're not going to know volume, so we're not going to be able to have an exact molarity. So we put the solute in first, then put the solvent. That'd be a good test question for you, by the way. Okay, so now we know the volume, the quantity of solute, because we put that in first. We know the water, the volume, so we know now moles and liters, so we can figure out the molarity on this. There are several types of molarity problems that we're going to do. Let me give you an example of some of them. Like, how would I make the following sodium chloride solutions? If I want to make a 1 molar a 0.5 molar, and a 2 molar. What would I need to do? Well, remember, molarity is moles per liter. So to make first thing I have to find out is what's my molar mass, or what does 1 mole of sodium chloride weigh? Look at your periodic table. I'll save you the time. It's 58.44 grams per moles. So to make a 1 molar solution, I'm going to put 58.44 grams of sodium chloride in a 1 liter volumetric flask, and then I'm going to add deionized water to the 1 liter part. Well, what if I want to make a half molar? Well, I need half as much, so I'm going to take half of 58.44, which is 29.22, put that in my volumetric flask, fill it up to 1 liter. And I'm guessing you can figure out what we do for the 2 molar. We double it. We put 116 grams in, and then add our water to the 1 volumetric flask. Pretty easy. So solve for molarity, like I said, it's moles per liter. Try this problem. If we have 75 grams of sodium hydroxide is in 500 milliliters of solution, what's the molarity? Well, we start, as always with these, we're going to be doing dimensional analysis again, so we start with what we're given. Well, here I'm given two things. I'm given that I have 75 grams of sodium hydroxide in 500 milliliters of solution. Well, I got to get the moles per liter. So the first thing I'm going to do is convert the grams of sodium hydroxide into moles. Well, 1 mole of sodium hydroxide weighs 40 grams. So now my grams cancel out here. Those cancel out. Now I got to get rid of my milliliters. Well, if you remember back, that 1,000 milliliters equals 1 liter. Now my milliliters are canceled out, and I'm left with moles per liter. So I multiply the top and then divide by all the bottom, and I end up with a 3.75 molar sodium hydroxide solution. Let me have you try this one on your own. Pause the video here, copy this down, answer it, and then come back when you're done. Alright, you done? You didn't cheat, did you? I want you to do this on your own. If you cheated, stop now. Do this on your own. Okay, we have what we want. We got 9.8 grams of H2SO4, which is sulfuric acid, in 100 milliliters of water. Once again, grams to moles, milliliters to liters. Okay, I have 1 mole, it weighs 98.08 grams. I know 1,000 milliliters in 1 liter, and I end up with a 1 molar solution. Doesn't matter if I convert grams to moles or milliliters to liters first, it doesn't. I just like to start at the top, which is why I would do that. Alright, here's our second type of solution. How would I prepare 100 milliliters of a 1 molar potassium chromate solution? So I know the molarity that I want, and I know the volume, but what am I really looking for? Well, I know the volume is going to be 100 milliliters. What I need to know is how much potassium chromate do I need to put in there? How many grams do I need to add to 100 milliliters? Well, like always, we start with what we're given. Well, I'm given two things here. My volume and my molarity. Which one should I start with? Well, let's start with molarity because that makes more sense. Well, 1 molar solution, that means that I have 1 mole per 1 liter. Now I want to get the grams, so I got to go from moles to grams. Remember, I'll put 194.19 grams of potassium chromate at top over 1 mole. Now I'm dealing with liters, milliliters, so I got to go from liters to milliliters. I know 1 liter is 1,000 milliliters. Okay, now I'm left with moles cancel out, I'm left with grams, liters cancel out, I'm left with grams per milliliters. But my question really is how many grams? So I have to get rid of my milliliters. So this is where the volume comes in. I add on how much volume I want. Now my milliliters cancel, and I'm left with grams. I multiply and divide and end up with 19.42 grams. I want to get me a 100 milliliter volumetric flask, add 19.42 grams potassium chromate, then add the deionized water up to the 100 milliliter mark. Okay, you try this one on your own. Don't cheat this time. Pause it, come back and see me when you are done. Okay, same as last time. We start with what we know. I have 0.5 moles per liter. I'm going to convert from moles to grams, and then go from liters to milliliters, and then finally it says it wants to be in 100 milliliters, so I put that up there, and I'm left with grams, and it's 4.90 grams. So I put 4.90 grams in a 100 milliliter volumetric flask, add water to the line, and that's how I make it. Okay, our next type of problem is dilutions. Think back to when we talked about solubility. We talked about you making Kool-Aid as a kid, right? You said you put 2-3 cups of sugar in, made it really sweet. Now you can't just take that sugar out, but what you can do is pour about ½ cup of that and then dilute it with water, and that's all we're talking about with dilutions. Okay, well, concentrations are often diluted to make a solution with different concentration. Here at TV, when we buy our chemicals, our liquid chemicals like our acids, we don't buy them in a 10 molar or 6 molar or 4 molar. We buy one concentrate like a 12 molar, and then we dilute that down to get what we need. It's more economical to do it that way. Okay, so dilutions are made by changing the volume. We're diluting, we're adding water in our case to it. So imagine this, you have your beaker, here's your concentration, and now we're going to add some deionized water. And what we see happening then is that the number of particles doesn't change, but the volume changed, so we've spread it out. We've increased our liters, so we get a smaller molar mass, or smaller molarity. Okay, to do this, a pretty simple formula. It's M1 V1, molarity 1, volume 1 is equal to molarity 2, volume 2. It's a simple ratio there. And basically what we'll do is we generally will have 3 of the 4 factors, and we're solving for the 4th by generally dividing. And here's the thing, the volumes can be either in liters or milliliters as long as they're the same on both sides of the equal sign. It doesn't matter which one you work in. A lot of times I work in milliliters because I need smaller quantities, so it's much easier. Okay, so let's try this first practice problem. How many milliliters of water would require to dilute 11 milliliters of a 0.54 molar acid solution to a concentration of 0.12 molar? Well, first thing you need to do is figure out what M1 V1 is. Well, here's the first one we come to, so here's M1, there's V1, here's molar, so this is V2, and M2, and we're looking for milliliters, so that's V2. So we're going to use this equation, so we have 0.5 times 11 equals 0.12 times V2. How do we get V2 by itself? Well, divide each side by 0.12, and when we do that, we get 41.25 milliliters. Now here's the thing to realize. That's our final volume, okay? But we already started off with some liquid. So to figure out how much water we have to add, you take we take our 41.25, which is our final volume, subtract the 11 milliliters up here that we started with, okay, which gives us 30.25 milliliters of water that we have to add. So we put 11 milliliters in and then add 30.25. In this case, since we're doing acid, we'd start with 30.25 and add the 11 milliliters because we always add acid for safety. Okay, let's try this problem. You have a stock solution of sodium sulfate, which is made with 147.2 grams of sodium sulfate in 500 milliliters of water. So I make the solution up, and then I'm going to take 20 milliliters of this and dilute it to 100 milliliters, and I want to know what's the concentration of this new one. Well, so I'm solving for the final concentration. That's M2. I know the volume of it's going to be 100 milliliters. I started with 20 milliliters, so that's V1. What I don't know right off the bat is M1, but they give me the information to solve this. I know that I made it with 147.2 grams in 500 milliliters. So figure out the molarity from that. Take 147.2 and convert grams to moles, milliliters to liters, like this, and I end up with 2.08. That's M1. V1 then is just 20 milliliters. So I set M1 V1 up there, and what I'm solving for is M2. I divide this side by 1,000, and I end up with 0.42 molar for my second concentration. All right, you try this one on your own here. Come back and check your work when you get it done. All right, let's do 2 of them. I lied. All right, try these 2 problems here on your own. Pause them and then come back and see me. Okay, so the first one, M1 V1, we take 150 milliliters, which is our V1, our molar, our M1 was 0.12. We're solving for M2, gives us 500 milliliters. Once again, divide this side by 500, and you get your molar mass, or excuse me, your molarity. I keep saying the wrong thing. Okay, with our second problem, we were solving for V2, and we end up with 50 milliliters, what we need of the original one. So we're going to place 50 milliliters of a 1 molar solution in a 250 milliliter volumetric flask. And then what we're going to do is we're going to add the deionized water up to the 250 mark. So approximately, it should be 200 milliliters if everything works out right. By adding this water, we're decreasing the concentration. Let's try this problem. How many milliliters of water are required to dilute 500 milliliters of 3 molar HCl solution to a concentration of 1 molar? So V1, M1, M2, we need V2. Here's what we're solving for. Okay, so our final volume is 1500 milliliters. But remember, what we're going to do is we're going to take 500 milliliters of our 3 molar, put it in a 1.5 liter volumetric flask, and fill it up to the point. We're filled up to that point there. So we need actually 1,000 milliliters of what we are adding to that. Okay, it's a little tricky here. You got to make sure read what the question is asking. It's not asking for a final volume. It's asking how many we want to dilute. One other type of problem is the percent solutions. Okay, percent solutions are simply a concentration of a solute being expressed as a percent of solution by volume. We generally do this in milliliters. So for example, we take isopropyl alcohol, okay, put 20 milliliters of this into it, dilute it to 100 milliliters, we end up with a 20% solution. Okay, so our equation is this: the volume of the solute over volume of solution. So in this case, we had 20 milliliters over a total volume of 100 milliliters times by 100 to get our percent, and we get a 20% alcohol solution. Pretty simple there. We can also do this if we're dissolving a solid in a liquid. Okay, instead of being milliliters per milliliters, it's going to be grams per milliliters. Same equation, except our mass is now in grams rather than milliliters. Example problem would look like this. A solution contains 2.7 grams copper 2 sulfate in 75 milliliters solution. What's the percent of solution in mass per volume? That's mass per volume is what it stands for there. So we take 2.7 grams, divide it by 75 times 100, and end up with a 3.6% solution. Okay, how about this one? How many grams of magnesium sulfate are required to make 250 milliliters of a 1.6 mass per volume solution? Well, in this case, what we're looking for is the grams. Okay, so I set it up as I did before, and I have to solve for my question mark here, or my grams. So if I rearrange it, okay, I end up with 4 grams of magnesium sulfate dissolved in 250 milliliters will give me 1.6% solution. Okay, try this one on your own and come back and check it when you're done. Alright, once again, we're trying to find the grams, so we set it up as same and then rearrange our equation as such and end up with 22.5 grams of sodium chloride. Hopefully this is pretty easy for you guys and the rearranging the algebra is not giving you any problems. Okay guys, we went through a bunch of different concentration problems today. Yes, you're going to be required to know all of them, so you need to practice them. If there's any you're not understanding, as always, please come see me. We'll do a couple worksheets in class on practicing this, but you really got to understand it. Be careful when we're doing those dilutions. Are they asking for the final volume, or are they asking for how much you have to add to your original volume? So very important on that. Well, until next time, guys, take care, and if you have questions, please come see me in class so you don't get lost in this. Take care. Bye.